Let's start with Chapter 21, Hacking Web Servers. First question that comes in mind is how a web server works. As we enter domain name in URL, it will break the URL into three parts, namely protocol, server name, and file name. For example, http www.innovus.in/webserver.htm is the URL. Here, protocol is HTTP, server name is www.innovus.in, and file name is webserver.htm. The browser communicates with the name server to translate the server name www.innovus.in into an IP address, which it uses to connect to the server machine. The browser then formed a connection to the server at that IP address on port 80. You can see in the diagram that the browser connects to the server and requests for the page, and the server sends back the requested page to the client. In this way, client and server communicate with each other. Here is a working process of web server in which, following the HTTP protocol, the browser sends a GET request to the server asking for the file. For example, http www.innovus.in webserver.htm. The server then sends the HTML text for the web page to the browser. The browser reads the HTML tags and formats and display pages onto your screen. What are the loopholes of web server and web applications? Some of the loopholes are listed below, such as injection attacks, PHP remote file includes, cross-site scripting, cross-site request forgeries, and insecure communications. These attacks are explained in their corresponding modules. Some of the popular web servers which are in current operation nowadays are Apache Web Server, Microsoft IIS Server, IBM Lotus, and Lite HTTPD. If any vulnerability is present in these servers, then malicious hackers can take advantage of that vulnerability and cause damage. Listed here are some of the server vulnerabilities, such as Apache vulnerability CVE 2013-2249, in which mod session dbd.c in the mod session dbd module in Apache HTTP server before 2.4.5 proceeds with save operations for a session without considering the dirty flag and the requirement for a new session ID, which has unspecified impact and remote attack vectors. Another vulnerability is CVE 2013-1896, in which mod dav.c in the Apache HTTP server before 2.2.25 does not properly determine whether DAV is enabled for a URI, which allows remote attackers to cause a denial of service via a merge request in which the URI is configured for handling by the mod dav svn module, but a certain href attribute in XML data refers to a non-DAV URI. One more common vulnerability is CVE 2013-1862. Here, mod rewrite.c in the mod rewrite module in Apache HTTP server 2.2.x before 2.2.25 writes data to a log file without sanitizing non-printable characters, which might allow remote attackers to execute arbitrary commands via an HTTP request containing an escape sequence for a terminal emulator. Another vulnerability for Apache is CVE 2012-4558, which includes multiple cross-site scripting vulnerabilities in the balancer handler function in the manager interface in mod proxy balancer.c in the mod proxy balancer module in the Apache HTTP server 2.2.x before 2.2.2 for dev and 2.4.x before 2.4.4 allows remote attackers to inject arbitrary web script or HTML via a crafted string. Another vulnerability is CVE 2012-4557. Here, the mod proxy AJP module in the Apache HTTP server 2.2.12 through 2.2.21 places a worker node into an error state upon detection of a long request processing time, which allows remote attackers to cause a denial of service or worker consumption via an expensive request. Another vulnerability is CVE 2012-3502. Here, the proxy functionality in modproxy AGP.c, the modproxy AJB module, and the modproxy HTTP.c in the modproxy HTTP module in the Apache HTTP server 2.4.x before 2.4.3 does not properly determine the situation that requires closing a backend connection, which allows remote attackers to obtain sensitive information in opportunistic circumstances by reading a response that was intended for a different client. Listed here are some of the attacks which can be performed against IIS or Internet Information Server. Some of them are listed as path traversal, known worms, remote command execution, probes, denial of service attacks, and compromised servers. Now let us take a look into the components of IIS. To configure IIS web server more efficiently, you have to understand first the core component IIS. There are a lot of IIS components available, but some core components are listed here, such as HTTP protocols maintained by http.sys, worker process, www service administration and monitoring. Let us take an overview of the components of IIS, such as HTTP protocols or http.sys. When you create and host new website, then IIS registers your site within http.sys, which will respond to any hypertext transfer protocol request for the website. http.sys is a driver used by IIS. In IIS, requests are processed faster and the services will not be interrupted when a worker process fails. HTTP protocol stack provides following services in IIS 6.0, such as routing HTTP services to the correct request queue and caching of kernel mode requests, and the last one is performing text-based logging for www service. Another component of IIS is worker processes that will process the requests like returning a static page or running a CGI handler. It uses http.sys to receive and respond to an HTTP request. You can configure IIS to run multiple worker processes. Another component of IIS is www service administration and monitoring. Like http.sys and worker process, this component contains critical IIS functionality that never loads external code. It is responsible for managing the worker processes. It includes starting the worker process and maintaining the information about running worker process. Now let's see about IIS directory traversal. Microsoft Internet Information Server could allow a remote attacker to view directory listings on the web server. Due to a vulnerability in the Web Distributed Authoring and Versioning search function known as WebDAV, a remote attacker could exploit this vulnerability to find and view certain files on the system, such as .inc files, which can contain sensitive information including usernames and passwords. To solve this issue, what we can do is, for directories containing sensitive information, we can disable the index this resource option, or we could disable or uninstall the index server if it is not required. Let us now look into Unicode and Unicode directory traversal vulnerability. Redworm, Redworm 2, and NimdaWorm exploited the Unicode vulnerability of the IIS server in order to achieve their motive. There are two major vulnerabilities. The first one is IIS PWS extended Unicode directory traversal vulnerability, and the second one is IIS PWS escaped character decoding command execution vulnerability. You can see the snapshot of the tool iisexploit.exe, which is used to exploit the vulnerability of IIS web server. In the same way, there is one more tool named execis win32.exe, which is used to exploit the IIS directory traversal and take commands from a command prompt and execute the exploit on the IIS server. Now we shall take a look into RPC DCOM vulnerability. RPC DCOM vulnerability exists in the Windows Component Object Model subsystem, which is important service used by most Windows applications. It was detected in July 2003. DCOM service allows COM objects to communicate with one another across a network, and DCOM service is defaultly activated on Windows NT 2000, XP, and 2003. RPC protocol allows a program to run code on a remote machine. By this, attackers can reach for the vulnerability in COM via any of the following ports, such as port number 135, which is used for remote procedure call, port 139. NetBIOS session service runs on this port, and all the file and printer sharing on a Windows machine runs over this port. Port number 445. TCP port 445 is used for direct TCP IP MS networking access without the need for a NetBIOS layer. Port 593. HTTP RPC EPMAP Distributed Component Object Model and Microsoft Exchange Server Services. You can see Internet Information Server logs in file locations, system root/log files. If proxies are not used, then IP can be logged in log files. Otherwise, one more task is increased to find out the details of the fake IP address, which is part of the forensics department to investigate this fact. To fix the problems arised by different vulnerabilities, we can use hotfixes and patches. A hotfix is defined as a code that fixes bugs in a product. The users may be notified through the vendor's website, or if you are a client, then they can send through email. Hotfixes are sometimes packaged as a set of fixes called a combined hotfix or service pack. A patch can be considered as a repair job for a programming problem. That means to provide the alternate code which does not contain vulnerability of the previous code. Now it is important for us to understand the countermeasures for web server attacks. Some of the countermeasures which are used commonly nowadays are such as use well configured firewalls, rename your administrator account that is not easily predictable, remove unused applications if present in your machine, disable directory browsing, service packs, hotfixes and templates, analysis of malicious input in forms and query strings so that attacker will not take benefit of that, and disabling remote administration. So this will be all for the module on web server hacking. Next up will be a demonstration for the same. Thank you. In this demonstration, we shall be seeing how we can inject various files into a web server in order to compromise it. So for this demonstration, I have set up a local server, local web application where we can test this concept. So this is the URL for that application. So just type in the URL and we gain access to the login. The login panel can be bypassed via proper assessment and trying to see brute forcing and trying to find out the username and password for that. You can set the IDS settings to low so that you can inject the shellcode properly. Otherwise, you will have to use various evasion techniques. So we shall be looking here for a browse option which is given over here. Here we have to choose an image to upload. So for this file that we are going to upload, we shall be uploading a shellcode which will give us a backdoor interface to the application. So opening this in a text editor, we can see that this is the shellcode which I shall be using, and this is base 64 encoded so that it can bypass filters properly. Now what we have to do is we have to rename this to a JPEG file, because for the application to accept this file it has to be a image format. So we shall be changing it to any name such as latest.php, and looking into the properties of the application we can see that it is a JPG format image, but basically contains the shell code which we shall be trying to inject into the application. So clicking on browse, we have to select the image file and click on open. So we have selected the image over here. So before trying to upload, we have to install an add-on called as tamper data. Tamper data is used to intercept requests given by the browser and tamper with it and modify it according to our needs. So just click on upload and we will get this interface, and clicking on tamper, so you'll get a interface where it will show various parameters of the requests such as the header details and what is the data that you're trying to send to the server. So if you just wait for a while, here it is. So looking into the post data, this will give you the kind of data that you are trying to send to the server. So browsing down this content, you'll be able to see that this is the file name of the file which you are trying to inject, and below this will be the actual content of the file. So just have to rename it to a PHP file, as the server executes only files based on the PHP framework. So renaming it and clicking on OK, you can see that we have successfully injected our shell into the application. Now through this we have created a backdoor access which we can access anytime from a different interface than the application. So we just have to know the URL of that shell code. So typing in the URL such as dwwa/hackable/uploads/latest.php, which is the file that you have injected, and it has gone into this directory of the server, we can see that we get an interface for the shell code. So typing in the default username and password for the shell, which we can change of course via the text editor, and here we can see that we have gotten access to the server, and which includes various details of the server including the server IP and the disk space utilization and the directories and different features of the shell code such as denial of service, different PHP based injection, exploits, 404 page malware attacks, cPanel tracker and the like. And down here we have different other options such as we can upload files over here and we can execute any commands, or we can browse to the directories and see what all are the folders and files in the web application. We can deface the application easily using this. So these are various options present in the shell code, and here this is the current directory that we have gotten into. So it is important for us to know the security perspective of this, as this is the method of injecting shellcode into the application. The process for mitigating such threats would be to install a proper web application firewall or an IDS, such as those inbuilt into the applications like DVWA, which will filter the user input and based on that prevent such attacks. Shellcode is a very powerful tool which is used to hack most of the servers nowadays, and you can actually compromise the whole server from just one website. So this is all for the demonstration. I hope it was informative.